Welcome to solverfy.
Now I asked to look at the system of a bullet hitting a block, but in the case now that it's underdamped. Natural frequency is the same, but now our equation governing them or describing the motion is this expression here. So we have exponentially decaying oscillations, and we have our damped natural frequency here. Now, again, we have our initial conditions the same as before. So in this case, we get that phi equals 0, and c is this expression. So our equation describing the motion is this. Now, again, they ask for what the maximum compression of the spring is. Well, that occurs when this is 1. And when that is 1 when t equals pi over 2 times omega d. So that is the time when it occurs. Now we can plug in this time into here, and this will give us 1. And the time that into here, we get this in the exponential term. Now omega d is omega n times the square root of 1 minus zeta squared, and zeta squared is this, where mt is the total mass, this guy here. Rearranging, we get this expression for the damped natural frequency, which we can plug in there and plug in here. And again, doing a bunch of just some algebra and simplifying, we get this ugly expression for our maximum displacement. And in this case, we can again see that, again, if little m is much less than big M, which we would expect, then you can see that this scales linearly with the mass of the bullet, and it also scales linearly with the velocity of the bullet. And now how it goes with K, capital M, and C is complicated, and in fact, deriving this is not all that useful because it's hard to really see what's going on. We'd have to make a bunch of plots to see how this changes as the stiffness and the damping and the mass of the block change.